Today's topic is about the trade-offs of using a local Kubernetes cluster or a remote Kubernetes cluster during the inner loop of development, and under what circumstances you might opt for one over the other, sort of comparing and contrasting, and a very, very brief demo. But this is mostly kind of to share our learnings of which kind of scenarios and which phases of the project's development are a good fit for each. Now, before we dive into that, I think we should address the question of why we should be using Kubernetes during development at all. I mean, I think a lot of companies that use Kubernetes in production do not use it in development. And well, primarily the reason is that the alternatives aren't that great. You need some way of running your services during development. If you're using Kubernetes in production, that means that you have, well, usually not just a monolith or not just one or two services. It usually means that you have a bit of a stack. Where if you have only a few services, maybe some of them are large, and even if your services aren't that big, the production configuration, if it's done in Kubernetes, contains subtle things, differences in networking, differences in how the system behaves, that mean that sometimes things come up during in production or in a higher environment that does use Kubernetes that don't come up during the inner loop. And so, but anyway, like the options if you have a Kubernetes system in production for development are, for example, Docker Compose. That's something that we commonly see, where you basically have you have your Docker files, and Docker Compose is like enables you to wire them together, have them communicate with each other, start up a development environment on the local machine. But the minus there is that it's not your Kubernetes manifests. You have another set of configs to maintain, and if you make a change to your Docker Compose configuration, you have to make the same change to the production configuration. And if there's there can be mistakes there, you have to map concepts. And no matter how well you do that, it's never quite like production. The other approach would be to just start a bunch of terminal tabs and run your services locally, and then maybe use a shared maybe staging backend or some kind of shared environment for whatever services you're not developing on. And this can be quite nice in that it's like it's fast if your laptop can cope with the services. But it's not like production at all, of course. It's running on your laptop, which may be a Windows or a Linux or a Mac machine, which different versions of the OS, subtle differences in the versions of the libraries. There's kind of no tractable way to really control what versions of the tools you're using. Like, are you baking these cookies with Flour version 1.1 or Flour version 1.2? The Flour version 1.2 might result in slightly different tasting cookies, which may or may not be what the bakery wants to sell to its customers. And so, in addition to that, so you have to stay on top of all of those tools. So this brings us to the benefits of using Kubernetes during development. So because you're using your Kubernetes manifests, you get a reasonably production-like environment right off the bat. Of course, just using the Kubernetes manifests themselves is not in itself an automatic guarantee that everything is completely production-like. There are other things like, are you using a different kind of database? Are you shimming certain things? Are you using simplified versions of certain databases that may behave slightly differently or have different capabilities and so forth? So it's it's usually not completely that, but it is at least much easier to achieve when you're using Kubernetes to at least run the Kubernetes part of the system, because that's kind of quite standardized. And without something like Garden, it's kind of tricky to automate the things around it, like interpolating in the you perform a build, you want to change the image version that's referenced in some manifest or some Helm chart, and then applying that, doing a dependency order. That one of the reasons why people aren't using Kubernetes in development maybe as much as they could be, given how powerful a machine it is, and given that it is the reference platform that the system is running on in production, is really just like a lack of automation. And that's kind of one of the things that Garden is aimed squarely at fixing. So with Garden Deploy, Garden Test, Garden Dev, you got those workflows covered, like deploying your stack, testing it, iterating on it. And again, because you're using the production stack, your production configuration, your deployments, production deployments, you don't have to maintain a separate set of configurations for development. You just use your production config, and you maybe inject some different config values, like you use fewer replicas, or different different resource requests and limits depending on the situation. But you get much more bang for your buck, as it were, from your production manifests and your CI manifests, because you're able to reuse them in dev. And again, because your environment is able to run all or most of your services, running integration and end-to-end tests, which also in some cases might rely on the production setup, is more doable with Garden. Sorry, with Kubernetes, and Garden sort of makes that more possible, because it sort of adds that layer of automation on top of the machine that is Kubernetes. Whoops, I think I left this one in there from the Helm charts presentation. I copied this over. So we have two basic options. You can run Kubernetes on your dev machine, or you can run, use a remote cluster to develop against. Now, the pros and let's just look at the pros and cons of each approach. So the pros of local Kubernetes is that it runs on your laptop. It's simple to set up. You just install Docker Desktop or Minikube or what have you. You can get started really quickly. If you're a programmer, or you maybe don't have all the credentials for the cloud provider, or you haven't gotten approval for the project yet, you could just start poking at it. There's no admin required. It's really lightweight. You can you don't have to worry about provisioning a cluster, RBAC, all that stuff, container registry. There's just less hoops to jump through to get out of the gate. And if it's a small project, it could be quite fast, and it can actually be not a bad solution if you're in the early stages, for example, of developing a containerized application where it hasn't really become that heavy. It doesn't take that long to build. It's pretty lightweight, pretty snappy. Then you're running it in production with Kubernetes, and just run it locally. That's fine. And also it's great for little experiments where you may be adding a service, or you're starting a new project, and there aren't that many other developers working on it, and you just want to be able to try something out without sort of going through all of the full-on configuration of a remote cluster. I mean, I don't want to make it sound like it's a lot of work, but there are a few more sort of components to it, like the container registry, the registry secrets, and all that stuff. But the cons of local Kubernetes, well, the first one is the same as the first benefit of the other one. It is running on your laptop, and it can make your laptop sweat, because if you're running a big stack, you have several services, maybe a couple of databases. Even if you're running on a high-end developer machine, it's usually just not feasible to efficiently run the entire stack on a single dev machine. When you're beyond 2 or 3 databases or 4 or 5 services or what have you, that just becomes very heavy. Your Docker daemon runs out of memory. That's another kind of maintenance hassle of using local Docker when you're doing a lot of builds. It's hard, yeah. So it's heavier on the dev machine, and again, it's not quite production-like. There may be subtle differences that creep in here and there between the local Kubernetes environment and the remote one. And finally, there are a lot of flavors. There's Minikube, there's Docker Desktop, there's Kind. I don't know. I think there's a few. K3s is another one, and there may be subtle differences in how these things work on Mac OS versus Linux versus Windows. Whether it's an M1 Mac or an older Mac, and as a developer experience team or whoever is responsible for the development environments for your team or for your organization, it's just a little bit more surface area to support, because with a remote cluster, everyone's running in the remote cluster, and the only thing that dev machine is doing there is making API calls and sort of interacting with that standardized remote environment, so which is kind of then exactly the same across the different developers. And conversely, for remote Kubernetes, because it is a remote cluster, it's easier to make it be fully production-like. It can really literally be the same production manifest, talking to the same cloud services, maybe with slightly different configuration, same cloud provider, same performance characteristics. Like if a certain thing tends to be slow on Azure, and you see that during development because you're also developing on Azure, you might identify performance bottlenecks and be able to debug that stuff more easily in a development environment, because you are using it's more of an apples to apples transition. And because it's all running in a remote cluster, your laptop is no longer sweating from the CPU cycles and all the RAM that's being expended on spinning up and operating all these services. If you're using Garden with this, which is kind of what we're recommending given the place we're at in this conversation here, it can feel just as snappy as local. You have dev mode to synchronize code into running containers, reload them, running tests and so forth. And in fact, it can often be more snappy than local, because if you're running a large stack, you can just have a beefy dev cluster that can easily cope with the weight of your stack, and your laptop is not at a 99% CPU. Builds and deploys being slowed down by the fact that your laptop can't cope. So in that kind of situation, if you're working with a heavy stack, it really is quite a lot snappier than local. And there are some other benefits, not least of which is the shared layer cache. Now the thing is, if you're doing Docker builds locally, you have a layer cache, of course, in your local Docker daemon. But let's say someone else on my team has built a service at a particular version. The build takes 5 minutes on Docker. I will have to repeat any layers in the build that I have not performed on my local machine. Whereas with remote building, which of course only makes sense when you're using a remote cluster, you basically are able to use the container registry as a shared layer cache across a dev team. So for example, when I'm working on Garden Cloud using remote development and I deploy off the main branch, I never have to rebuild the container because I'm deploying off a version that's been, almost by definition, built by someone else on my team for that version hash. So that's quite nice and can lead to real cost savings, especially if you have expensive image builds. And finally, kind of like I alluded to earlier, it works the same for all developers because you're literally all just have different namespaces in the same cluster, and you're kind of factoring out the subtle differences in environments that may occur between a Windows developer, OS X developer, Linux developer, all working on the same kind of application in the same cluster. Now, there are some downsides. As I also mentioned earlier, remote clusters are a little bit harder to set up. Not very hard, but there's just like a few more steps. You need a container registry. You need Garden or whatever deployment tool is whoever's pulling the images to have the registry credentials to be able to push and pull images. You need to if you're in a sort of security sensitive environment, you need to set up RBAC around which developer can work on which namespaces, access controls, things like that. And dev clusters cost money. Some computer is sweating somewhere, and if it's not your laptop, it's a server somewhere out in the cloud. And while you do get more horsepower when you're able to run your when you have the automation you need to run your development environments in a remote Kubernetes cluster, this will in general increase your infra spend. Of course, one thing that I forgot to add a checkbox around that here, but one of the things that Garden Cloud does to help with this is automatic environment cleanup, which detects when namespaces haven't been used for a while, can sort of spin down resources in a given namespace when they haven't been touched for a certain number of hours or and so forth, which can also which can help to control those costs. But in general, it does mean an increase in your infra spend. But on the other hand, you can increase in general your dev team velocity, and developers aren't cheap. So it's usually more than worth it in terms of productivity, in terms of the total cost, if you look at it holistically. And finally, kind of a subtler point is that you are more exposed to variability in performance from the cloud provider. Like if the container registry is slow to respond, or there's some kind of outage or anything like that, it's you're working with a more distributed system when you're working with a remote development cluster. Like if it's just Docker on your machine, yes, your laptop is doing all the work, but it's just your laptop doing the work. It's not like your Kubernetes cluster talking to a registry, fetching over the internet, different computers. Usually it's all fine, but you are when things if your cloud provider is I'm kind of mostly thinking about Azure here, to be honest, not to bash on them too much, but these are complaints that we have heard sometimes from people who are doing remote dev on Azure. That's just something to consider, but I would say it's a minor point, and in general, it's far outweighed by the benefits of remote development. So broadly, what we recommend is start with local Kubernetes when you're putting your garden project together. You're writing up your Docker files, your Kubernetes manifests, your service dependencies, test dependencies, just getting everything working. Especially if it's like a new project and you haven't gotten approval from your bosses, or you haven't got the infra set up already, or you may not even have a dev cluster or whatever. You just out of the gate, just start with local Kubernetes, iterate on it quickly. And if you have only a couple of small services and a database or two, and the builds are pretty fast and it's not that resource intensive, then this might be enough for you. At least, for example, if you're early stage startup, you want to use Kubernetes in production, so you just went for that immediately. But it's one or two developers, you're both using the same platform, you both kind of are comfortable with that, it may be fine. But in general, and especially for anything beyond that sort of small size of system, we recommend that you move to remote development environments as soon as you're ready to roll out this development, these development workflows to the rest of your team. Because as soon as people are hammering on it day to day, these benefits that we mentioned for the remote Kubernetes builds really start to come into the fore. The shared layer caches, really important. Shared test caches also really important, which I didn't mention, but that's kind of similarly like, if somebody has run a given test suite at a given version, thanks to Garden, you're able to cache that. That's a benefit that you can only get when you're using a shared development cluster. And also, you have developers that have varying levels of comfort with Kubernetes and with ops in general. And the remote development environment makes it a lot easier for the ops and developer experience engineers to sort of help developers figure out what's going on. Like, instead of like, help, Kubernetes is misbehaving on my laptop, what even is it? When it's a remote development environment, first of all, it's exactly the same, for all developers. So, you're kind of eliminating that variable that, there might be something slightly different between that developer's particular machine. So you kind of take that out of the equation. And also just, it's just simpler to maintain and to roll out to a larger team. It's more performant, and it's generally worth it once you get serious and once the system gets to a serious size. So that's kind of how it generally breaks down for us. Let's just do a very, very brief demo. There's not really much to show in connection with this, but here I have a Vault project. So this project here is, I think maybe I should increase my font size a little bit since I'm on a big screen. So just to emphasize that with Garden, it is quite easy to sort of switch between them. If you want to have a local environment and the remote environment configured for your project, that is as simple as having different environments that use alternatively the local Kubernetes provider, which can support Docker Desktop, supports Minikube, a host of local Kubernetes options, and then have another environment or set of environments that uses a shared remote dev cluster, or basically any you just point it at any cluster of your choice, and Garden will figure that out. I tend to use remote dev all the time, but occasionally, occasionally I will use local development if it's a very small service, or if it's something new where I don't want to like where I haven't got the infra set up, then I might reach for that. But it is very, very fluid to switch between them. So typically your project would start out with kind of only this provider here, and maybe only the remote environment at the top here. And then you'll add this one as you roll to the dev team. But if in some context or at some point in time you're not happy with how your remote development environment is working, you can always switch back to the local one. It's just a matter of toggling environments and keeping on there. So yeah, I would just encourage you to try both, but we really recommend remote development environments, because I think it might be tempting to just avoid the all the setup steps that are related to remote Kubernetes, and just stay with local. But I think most teams will find that this is quite resource heavy. Laptops aren't great at running Kubernetes clusters, and remote development environments are, while they cost a little bit in terms of infra, can help you achieve a higher dev team velocity, can make it easier to roll out high performance development environments to a whole team in a way that's standardized across the organization, and where it gets out of the way of the developers and where it's easier to support that. So sort of the team level and sort of medium term plus benefits start to really accrue when you use remote development. So yeah, that is all I have to say in this presentation. So I guess we will open it up to questions and discussion right now.
I have a question. Are any customers? So we're looking to do this in the next month, and one of the things is we have quite a few services, right?
Mm-hmm.
And so cost is kind of a concern. So what
Yeah.
we're looking at is using, I think it's called KIDA, Kubernetes Event-Driven Autoscaler, where you can scale down your services to 0, like replicas, and then, if it's a worker process that listens to queue, it will generate a replica.
Yeah, that is actually a very interesting approach. I haven't heard about anyone doing that, but I think that, it's almost like sort of just in time deployment.
Not good.
Yeah. That's right. I got the gist of what you're saying there. So in effect, what you're describing is kind of like a just in time deployment.
And then can you hear me now? No,
not really. I mean, a fragment here and there, tantalizing fragments. I'm mostly following the gist of what you're saying, though. But yeah, I mean, to that point, like that does sound like an approach that can work if your system architecture supports that. So some of our customers and users, they do use variables and templating to configure, for example, deploy certain services in a shared environment, and then have a subset of services kind of live in that developer's namespace, iterating on those, but then talking to certain shared services. So you're only kind of, you don't have all the, you don't have, all the services times all the developers all the time. But how that pans out, particularly, like for example, what you're describing there is a great pattern. But how feasible it is, it really depends on, does your architecture support that? For example, are you able to do shared backend services in a way like, can you have are you able to distinguish between, like, you have a request that comes into a shared backend from a developer's personal namespace? Does that interfere on the database level with requests that are coming in from other shared namespaces? Yeah. Often it's possible, if your architecture supports that and you're able to dispatch that, correctly, then that can work great. Especially, for example, if you have some kind of like multi-tenant architecture, you're able on a database level. But you can conditionally deploy things and conditionally point parts of the system as shared backends. Garden makes that. We are actually working on, we're designing a new framework primitive in Garden which is sub projects, which enables you to deploy subsets of the services with particular configuration values, which you can then sort of point at a shared backend. But what kind of pattern you have around sharing services, and what pattern is best, that's kind of like guided and constrained by what's your architecture like. Are you multi-tenant or not? Or do you have an event bus or not? But Garden sort of tries to play nice with these different approaches, but it's hard to come up with a sort of standard pattern that can apply to any stack.
Yeah, we tried that. We were originally going down that approach of somehow just deploying a subset of services into your dev environment, and then kind of connecting back into some shared services. But our architecture doesn't support that easily, so we were looking at things like a service mesh to kind of route traffic conditionally based on flags, and it just got kind of complicated. And then we're like, and then I came across this KIDA, and then we're also spot pods in GKE as well, which you pay like 30% of the original cost. And I think with the combination of those two, it's and maybe deploying some local containers for some stateful infrastructure components, like a database. Yeah. We probably can get the cost down quite a bit, and then everyone kind of has isolation.
Yeah, this topic is kind of like I'm very, very interested in this particular topic, and I've been racking my brains about it for a while, and yeah, I mean, we have some patterns that that we've seen work for some companies, but it's so dependent on what properties your system has, and like this trade-off between the complexity of setting it up and supporting it, versus like does it cause weird bugs and weird maintenance burdens that end up slowing it down more and thus costing you money in terms of velocity more than you would save on the infra. So it's kind of a bit of an equation to balance there. But we want to do more on the Garden framework level to make it easy to use such setups and sort of like you can do all this already with environments and variables and nesting and sort of conditionally, like when this service, when the API service talks to API service number 2, if it's in shared mode, you just pass another endpoint URL for the shared service. But for that system to work as a whole, that depends on things that are kind of outside of the scope of Garden. But what Garden can do is it can make it easier for you to pick slices of the subsets and sort of do the wiring. But to ensure that this wiring results in a working system that's easy to develop against and to maintain, that's kind of a separate thing. But this is kind of a pet interest of mine is capturing more of these patterns on the framework level.
Nope, that makes sense.
And of course, there are options like mocking services and stuff. But it depends also on like how mockable are they, how complicated are they,
Good question, Thor. How often would developers actually need to test their microservices against other microservices in development while they're doing functional and unit testing, right, within their own domain? How frequent do you actually need to do like integration testing? Because it sounds like it makes a lot of sense if you have a lot of other microservices or other middleware that you want to talk to from your microservice, and having a sort of a semi stack being deployed in Garden makes a lot of sense. But if you're just doing functional testing, you're working on your manifests for Kubernetes. If we're using Helm charts, like you're working on your chart for config maps and PVCs and whatnot, right? Do you really need to have the full stack?
So that's a good question. I think it really depends on like what kind of testing do you do and what kind of testing do you need? Do you need to, for example, test flows that kind of end-to-end tests?
I'm talking about developing new, right? So you have a new feature, right? You have a microservice that you're working on, or somebody else's microservice. You're adding code to it. You're adding like maybe new logging, whatever, to this microservice, and you're doing local testing, right? You are and you're validating everything locally. And then once you're ready to test with other microservices or middleware, that makes sense to use Garden. But I'm not sure why you would need to have Garden on from the get-go. Like why would you want to use it?
Right. Yeah. So in that context, like for example, so what we see typically is that people, when you have a lot of integration tests or tests that that test interactions between services, if something does go wrong in CI, you try to make a fix locally, you push again, and you wait for the pipeline again. And then, the pipeline takes maybe, I don't know how long, 10 minutes, 30 minutes. And then, if you go through that loop too many times in a given work week, a lot of time is spent on that. Whereas if you're able to run all of these tests in your personal development environment and you have live code syncing, that means you can, for example, deploy the service that seems to be malfunctioning in dev mode, make some changes, reload it, rerun the integration end-to-end tests on those live services without having to go through a full CI pipeline. So you can sort of write new tests more sort of cheaply, because you have kind of the developer experience around writing and debugging integration end-to-end tests is kind of the same developer experience as you would get for unit tests, the same kind of immediacy. So it's really so how often you do that also that depends on what kind of tests you have and what kind of tests you need. Often it's fine to work on one service at a time, but it really is like we commissioned a survey last year about we had this independent firm interview 400 developers at different size companies, and we found that like people are wasting a huge amount of time, waiting on CI pipelines, wrestling with developer tooling, and just dealing with subtle errors that come up because of the differences between the development environment and the production environment, and being able to debug and run tests more efficiently in your local environment, and being able to iterate fast in a development environment that's production-like. It's like it just makes things, it can improve dev team velocity, but of course, like the degree to which you need that, of course, it depends on your stack.
Yeah, so I'm just wondering, I'm sure at a certain point of your development of this new feature, right? You would want to test, you will want to test it against other microservices. But before you get to that point, you're probably trying to build out your own functionality to make sure that it works first, right? And then at that point, you want to integrate it, test with other, microservices. So there's a lag, right, between use like doing it from day one, or start building something, and then you can sort of test your Helm chart or whatever the Kubernetes manifest, make sure that part works locally without incurring the costs and setup and all that. And then once you're ready, you can start testing your pipeline and so forth. So there's a period where I don't think you need to have Garden on day one. It seems like, right? Because you could
it depends. Yeah, so I suppose also like like when you're developing your feature or your service and it's talking to another service, like being able to see the logs on the other side, putting in console log statements, and just like having it at your fingertips can be useful if you're developing flows that are like front end talking to the back end. You want to be able to modify them both at the same time. But again, I mean, what you're describing makes sense in a lot of cases. So it's really just like, if the logic you're writing is mostly internal to the one service, kind of unit testable and functionally testable things that are mostly just like this one component, then you don't really need to have all the other stuff running. But once you have something that's like different components communicating, and you want to be able to sort of follow along everything that's going on in the development environment, put in log statements, do some debugging on more than one side, even though you're only working on one component, it can be sort of faster to reason about what's going on during development and debugging, even before you get to CI. At least I find that when I'm working on Garden Cloud, that it's nice to have that, front end of the API and the database and all that stuff in my own namespace. But again, it depends, and it also depends on like how comfortable the developers are with Kubernetes. But yeah.
Okay, thank you.
But yeah, it's a very good question, and I think in a way, like development environments are very demanding. In some ways, a lot more demanding than production. And sometimes you want to run a service locally. Sometimes you want to run it containerized. What kind of inner loop experience do you want? It really depends. What's the programming language like? What tooling do you have? And it's really a space where there aren't really any one size fits all solutions. But this is also like actually one thing to note here is that Garden, in the next release, we're going to be rolling out, I believe we've merged it now, locally running services as first-class services in Garden. So if you want to like run certain services on your local machine, and then have them talk to the rest of the services being running remotely, that works in a completely native way. So we're not like ideological about everything having to run remotely all the time. You can mix and match, but the reason why I'm sort of pitching the remote environments here is because the things that I mentioned there. But again, it's not a space that's amenable to one size fits all solutions. So it really depends on like where your company is at. How are you able to iterate quickly? What are the main concerns? And I think it just makes sense for people to pick the most practical option that gives them the right set of trade-offs for where they are right now. And that can change as the team grows, as the product changes, and so forth. So,
or the about that feature of extending the cluster locally is similar to like a telepresence solution.
So the telepresence part is not ready yet, but we are working on that actively, actually. Yes.
Oh, so it is using telepresence for this.
It's not using telepresence.
Oh,
it's using it's our own sort of hand-rolled lightweight version of that, because telepresence does some. We tried to integrate telepresence at the Garden, but unfortunately, it's unstable and slow with Garden. I'm sure it's fine by itself, but some of the magic that it does, like if you deploy if you set up Telepresence on a service, and then you deploy with Garden without Telepresence, then Telepresence gets into a funky state where it thinks that Telepresence is running and is not able to recover. So it kind of makes strong assumptions about what is in the cluster that are broken when you do other things with Garden. So it's also doing a lot of magic behind the scenes. So what we're doing is really a lightweight proxy from the cluster to the local process, so that the local process can receive communications from in-cluster services.
Okay, but similar functionality.
Yeah, similar functionality, exactly. Yeah, and but sort of more lightweight because you're not running it through Docker. Yeah. So, but also, that also means that Telepresence has certain benefits that our local mode does not have because it is Dockerized, whereas ours is, completely local, which makes it faster and more lightweight. But also, you do need to have the tools installed. But yeah, it's just because in a lot of cases, it's nice to have completely local development for the service that you're working on. If it's like you're running Webpack compiles or even, I don't know, like a Java service, and you want to just have it all be completely locally, like your debuggers, your IDE integration and all that. Sometimes, you just get a smoother experience running it completely locally. And, we want to play nice with that. And, spinning up the whole rest of the stack is generally more amenable to remote development environments. But that doesn't mean that you should be forced, if it doesn't fit your tool chain, to do everything remotely.
I have one more question.
Yeah.
So when developers work in the microservices, they are constantly making changes, sometimes automated, sometimes manual, right? So, and they're constantly building on top of their configurations with trial and error. So if we were to run these microservices in Garden, and if the cost of keeping those clusters up and running all the time, and you recommended that auto burn down feature that would shut down the cluster to save costs. Like how would that work, right? Because like when I'm developing something, I'm not done, right? I'm sort of configuring things halfway through, so I want to make sure that it maintains state, so I can come back the next day and start and continue working.
Yeah. So the way that works is like, this is a cloud feature, part of the Garden Cloud sort of offering. That's like, the commercial version on top of Garden Core. We're sort of constantly streaming events and log entries to Garden Cloud. So Garden Cloud knows which namespaces have been used recently. So, it wouldn't get scaled down while you're using it. It would kind of, you can configure it in various ways. But the classic use case is like for a development environment, you scale it down if the developer hasn't used it for maybe like 4 hours. So it's not like running in the night when they're asleep. But then if you have data, like, in a stateful set or something like that, we're just spinning down the replicas to 0, but the volumes are still there. So when you come into work in the morning, you do Garden deploy, replicas go back up, the system is live, and the data is still there. So you're not dropping the databases or the data sets there. So all you have to do really, when you want to start the environment again, is basically scale it up from 0 to 1 or 2, or what have you.
By the way, this feature is going to be released probably tomorrow with 1.19. It's not out yet.
Oh, okay. I thought it was out. Yeah.
Okay, so this is a way of sort of like suspending your workspace in a way, right?
Yeah, it essentially scales down all of the resources in the namespace. Yeah.
Okay.
So
yeah, I think Keto works like that too. It just sets the replicas to 0.
Yeah, exactly. Yeah. But so what automatic environment cleanup doesn't do is like it doesn't like detect that there's traffic coming in and spin it up. This Keto thing sounds kind of smart in that way, So it might actually be a nice sort of companion to AEC in that way. For the dynamically spinning up part, that is.
Yep.
Yes.
I had one. So the back to the inner dev loop of not having to build things yourself and just sync the code up into the container. So we run, I guess Java applications. Are there people that are using Spring Dev tools with dev mode to sync up change code automatically? Do you know of any customers? I think it can be done from the documentation, but we haven't got there yet.
I'm not aware of anybody that has done that yet, but I think, you know, there are ways to do it. It just, you know, it just needs a little bit of a, you know, special setup, because you need to have a container that contains the, you know, contains the POMs up the chain, and has the Maven tools and so forth. But
no,
yeah,
there's a Spring DevTools mode for Spring Boot that will detect changes to class files and automatically restart. So I think this sync should work well with dev mode. With the Spring DevTools.
Yeah, I was mostly just thinking of the case where you have like a sort of you know, some kind of if you have build config that lives outside of the module root kind of deal. You know, but in those cases, you can also, like, you know, you can have modules that you know, there are ways to make that work, but, you know, we probably need to sort of explore those in a little bit more detail and write documentation about the recommended patterns there. I mean, they are there, we haven't fully explored them yet.
Yeah. And do people usually mount like the class files and source code then to like empty dir, so that it's writing to the host file system versus continually writing to the is that like I think you get better performance, right, than just writing to the container file system if you're like continually making changes and building new classes and things like that.
I think I've seen both, but I do remember, I think, you know, I've seen a couple of users use the empty dir option, but I wasn't involved in those particular conversations. I just remember seeing them like peripherally. But yeah, I mean,
it makes sense to me to use empty dir for that.
Yeah, and I mean, you know, basically you can cobble this together using the Kubernetes primitives in whatever way is most optimal for your setup, in a way that the developer doesn't have to worry about. And we have helped people set up some pretty elaborate setups, you know, this way. But you know, it really just depends on, again. But Kubernetes is kind of nice in this way, because you do have a pretty broad range of Lego blocks to build this particular castle. So thanks everyone for showing up, and I hope to see you around next time. And
thank you. That was very good.
Thank you.
Cheers.